The data that we store in lists usually has an inherent order. So maybe we store a color as RGB values, so how much red, green and blue it contains. And for that we could have a list with the values 255, 0, 0, which would correspond to the color red. In this list, the order of values matters, and so we know what each value stands for. We have the red, green and blue intensity of our color, and if we were to switch any of these values, we would get a different color. If we now want to know the green intensity of our color, we can simply take the second value of this list. In another example, our data might consist of not just one color, but multiple. So here we have a list where we store some colors. In this example, our data has no established order, like we had with the RGB values. So there's no reason why this color comes in front of this color or after this one. And that makes it hard to find a certain color. So we would have to remember or keep track of which index corresponds to which color. And that can be very tedious. And so for these cases where we cannot rely on the data's inherent order to find specific values, Python provides us with dictionaries. In dictionaries, we can associate values with keys. So we can attach our colors to keys and then use these keys to retrieve the respective color. The syntax for dictionaries are curly brackets, and we can add key value pairs by first writing our key, which acts as a unique identifier for our value, and it can be any type of immutable object. So let's choose the string blue as our key. Next to the key, we put the associated value and separate them by a colon. Our values are the RGB colors, and so for blue, that is 0, 0, 255. Let's assign that to a variable and then we add another color. So another pair of key and value. And we separate the key value pairs by a comma. Our second color will be purple. So we again write the string purple, which is our key, and then separate it by a colon, and then put the RGB values. And finally, we can also add red to our set of colors. And for that, we can refer to our red variable that we defined up here. Okay, let's have a look at our dictionary. Printing the dictionary looks very similar to how it's written in the actual code. So we have our keys and then the respective values. To now access one of the values, so one of our colors, we make use of the respective key. And so we type after the dictionary square brackets, and in these square brackets we put our key. And if we run that, then we get the RGB values for the color red. We can also exchange it with blue to get the blue color, or purple. Now what happens if we try accessing a color that does not exist, for example green? This gives us a key error, so the key green was not found. So let's add the color green to our dictionary. And for that we write the same syntax. So our dictionary, square brackets, and then the key. And to that we assign our value. So for green it will be 0, 255 and 0. And if we now run our code, we see that we successfully added a new key value pair. The same way we add key value pairs, we can also change them. And maybe we're not happy with our purple color, and so we reduce its red intensity. And we can print the purple color before and after that change. And we see we go from the initial 230 to 220. One important aspect of data structures is that we can iterate through them. And let's start with the syntax that we used for lists. So for lists, we wrote for element in our list. Here we use the dictionary, and then we print the element. And what this gives us are not the elements in the sense of the values of our dictionary, but it gives us the keys. So blue, purple, red, and green. If we want to have the values instead, we can just use these keys to access the values. So instead of printing the element, we print colors, and then we enter our key. And this way we get all the values. We can also tell Python explicitly whether we're interested in the keys or the values. So if we add a .keys after a dictionary and then again just print the element, that gives us the keys, which is the same as not having the .keys, so that really doesn't make a difference. But if we replace keys with values, then we get the values. Sometimes it might also happen that we're interested in both, so keys and values. If that's the case, then we can use items. And this will give us both keys and values. And the way they are represented is in form of tuples. And what we can do is we can unpack these tuples already in the head of this for loop. So we can write for key and value, and then we can print the key separated by a colon and then the value. And that prints us first the key and then the value. And so we have access to key and values separately and not in form of a tuple. Okay, let's recap. Dictionaries are great if our data has no inherent order, but we still want to be able to efficiently find specific elements. We can find and also change elements or values by accessing their respective key. And when we want to iterate through the whole dictionary, we can use either keys, values, or items.